In the summer of 1950, the Los Alamos National Laboratory was home to some of the most brilliant minds on the planet. Men who had recently spent their time figuring out the most efficient ways to split the atom and, by extension, the world. But on this particular afternoon, the topic of conversation was significantly less apocalyptic. Over lunch, Nobel laureate Enrico Fermi and his colleagues were lawing about a cartoon in the New Yorker. A silly illustration depicting aliens stepping out of a flying saucer to steal New York City trash cans. It's a peculiar starting point for a crisis of galactic proportions, a joke about missing garbage. The table moved on to other topics, as people usually do, but Fermi didn't. He sat there in a brief and characteristic silence, his mind shifting gears. He began running a series of casual back-of-the-napkin calculations over the sheer physics and energy required to cross the void of space. Suddenly, right in the middle of a sentence about something else entirely, Fermi blurted out a question that would lead to one of the most famous and most frustrating inquiries in the history of science. But where is everybody? The table erupted in laughter. In spite of the question coming out of the clear blue, everyone sitting there understood at once that Fermi wasn't talking about the cafeteria. He was talking about the cosmos. But as the laughter died down, the seed of a terrifying concept had been planted. In the decades that followed, scientists would take the Fermi's casual question and apply the brutal math of time to it. They considered the age of the galaxy, some 13 billion years, and the time it would take a moderately ambitious civilization to hop from one star to the next, even at a fraction of the speed of light. The mathematical reality was the galaxy shouldn't just be inhabited, it should be colonized. We should have been visited long ago, many times over. And the question that remains is simple but vast. In a universe of billions of worlds, why are we the only ones left to ask why? To learn why the cosmos is perfectly still, we look at the numbers as scientists will. In 1961, Drake wrote an equation to show, not to solve the great riddle, but map what we don't yet know. It was a masterpiece of educated guesswork, designed to break down what we needed to know. It factored in variables like the rate of star formation and the percentage of planets that might develop life. Depending on how optimistic your numbers are, the Milky Way galaxy should be home to thousands of civilizations or absolutely none at all. This brings us to our first theory, the rarity of brains. While simple life appeared on Earth almost as soon as the planet cooled, it remained microbial for nearly 2 billion years. It plateaued. The jump from a simple single-celled organism to a complex cell with a nucleus, a process called cryogenesis, happened only once in Earth's history. If this leap is an astronomical fluke, the universe might be teeming with planets covered in microbial slime, but devoid of anyone to look back at us. But if intelligent life is common, perhaps the silence is intentional. In 1973, astrophysicist John Ball proposed the zoo hypothesis. It suggests that advanced civilizations are aware of us, but are intentionally avoiding contact, treating Earth as a protected nature reserve or a zoo, to allow us to evolve without interference. It's a comforting thought until you consider the non-exclusivity problem. For this to work, every single alien civilization in the galaxy across billions of years would have to agree to the exact same policy of non-interference. No rebels, no accidents. This leads to a far less optimistic solution, one rooted in cold game theory and popularized by the science fiction author Liu Cixin, the dark forest. This theory assumes that survival is the primary need of any civilization. In a universe where resources are finite and the intentions of a neighbor can never be known with certainty across the void, the only logical win condition is to hide. The galaxy is a dark forest. Every civilization is an armed hunter. To broadcast your location is to light a campfire in that forest. It isn't an invitation to talk, it's an invitation to be destroyed by a superior hunter who cannot afford to take the risk of your existence. While the theories differ in their specifics, they all converge into one structural framework, the Great Filter. It acts as an umbrella, organizing every possible solution into a simple question of timing. Proposed by economist Robin Hanson, it's the idea that there is a wall, a specific evolutionary step so difficult to clear that virtually no one makes it through. The mystery isn't whether the wall exists, but where it stands in our timeline. If the filter is behind us, we have already cleared the impossible hurdle. It means we are a rare anomaly, a cosmic success story in a universe of failures. But if the filter is ahead of us, then we are simply approaching the same dead end that has silenced every civilization before us. If that's the case, we aren't the exception, we are just the latest to reach the wall. If the filter is indeed ahead of us, we have to ask what it looks like. Futurist Nick Bostrom suggests that technology itself might be the ultimate trap. He compares our scientific progress to pulling out balls out of a giant urn of invention. White balls represent beneficial discoveries, like the wheel. Grey balls are mixed blessings, like nuclear energy. But eventually, any civilization may pull a black ball, a discovery that by its very nature destroys the society that finds it. We have been lucky so far, as Bostrom notes. If making a nuclear weapon had been as easy as baking sand in a microwave, the human story would have ended in 1945. The silence of the galaxy may simply be the sound of every other civilization reaching their black ball moment, just as they were about to reach the stars. For decades, we have looked towards the red sands of Mars as the ultimate prize. The discovery of even a single microscopic fossil would be hailed as the greatest scientific triumph in human history, a moment of celebration, a confirmation that we are not, in fact, alone. But to futurists like Nick Bostrom, this discovery wouldn't be a cause for celebration, it would be a bad omen, a death sentence written in the Martial dust. The logic is as cold as the void itself. If life emerged independently on two neighboring planets in a single solar system, meaning a completely separate biological origin and not just ancient microbes hitchhiking on asteroid debris shared between Earth and Mars, it implies that the spark of life is not a miraculous one in a trillion anomaly. It is a routine occurrence. It would suggest that the universe is likely teeming with simple organisms, algae, bacteria, perhaps even complex animals. And yet, despite a universe supposedly bursting with life, the galaxy remains silent. If life is easy to start but no one survives long enough to be seen, the conclusion is inescapable. The great filter, that impossible wall that stops civilizations, cannot be in our past. It cannot be the difficulty of our biological origin. Instead, it must be waiting for us. As the famous quote attributed to Arthur C. Clarke notes, two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. If we are not alone, we are likely in a forest of hunters or a graveyard of the dead. But if we are truly alone, we are the only guardians of the only light in the dark. For now, the universe remains quiet, and that silence is our only answer.